Hello everyone, I'm Vaibhav Gupta, and in this video, we'll understand the basics of reinforcement learning. And for that, we'll go over an example where we'll develop a value-based reinforcement learning algorithm called Q-learning to implement an agent that plays Frozen Lake. The basic idea behind reinforcement learning is that we create agents that learns from the environment by interacting with it and by receiving rewards for the action performed in that environment. In this example, we have used Q-learning, which is a value-based reinforcement learning algorithm in which we implement Q tables to store the maximum cumulative rewards for each state. So let's go ahead and understand how we implemented the Q-learning to play the Frozen Lake. So basically, the goal of Frozen Lake is very simple. We have to go from the starting state S to the goal state G by walking only on the frozen tiles. Here, we have to make sure that we avoid holes. However, the trick is that ice is slippery, so you won't always move in the direction that you intend to. Basically, the environment is stochastic. We'll start by first installing all the dependencies on the Google Colab. Here, I'm installing the NumPy dependency and the OpenAI Gym dependency. After installing the dependency, we'll import the three libraries that we'll be using. Here we are using NumPy for our Q table, OpenAI Gym for our Frozen Lake environment, and random to generate the random numbers. After I've imported the dependencies, it's time to create the environment. Here we'll be using the OpenAI Gym library, which consists of many environments that we can use to train our agents. In this example, we are using the Frozen Lake environment. After importing libraries, we'll create the environment. So once we have created the environment, it's time to create the Q table and initialize it. But before creating the Q table, we need to know how much rows or states and columns or actions we need. For that, we need to calculate the action size and the state size. Fortunately, OpenAI Gym provides us a way to do that. Environment.action_space.n gives us the action size, and environment.observation_space.n gives me the state size. So once I have calculated the action size and the state size, it's time to create the Q table by initializing the state size, which is 64, and action size, which is 4 to zeros. So this will create my matrix of 64 into 4 with every value initialized to 0. After creating the Q table, it's time to define our hyperparameters. Here in this example, my total number of episodes are 20,000. My learning rate is 0.7. My maximum steps per episode is 99. And my discounting rate, which is gamma, is 0.95. For the exploration parameters, my exploration rate, or which is my epsilon, is 1.0. My maximum epsilon, which is my exploration probability at the start, is 1.0. My minimum exploration probability, which is my min epsilon, is 0.01. And my exponential decay rate for the exploration probability is 0.005. So now we have defined our hyperparameters. It's time to implement our Q-learning algorithm. We'll be implementing the Q-learning algorithm in 5 basic steps. First, we are going to initialize the Q values arbitrarily for the action state pairs. Second, we are going to reiterate over the total episodes and total maximum steps or till the learning is stopped. So here I'm going over the total episodes and total maximum steps. After that, as a part of third, we will choose an action A in the current world state S based on the current Q value estimates. So we are using the current state S to choose an action A. So after we have chosen action A, we are going to take that action A and observe the outcome state and the reward generated. So here I'm in the environment, I'm taking that action and I'm storing the outcome state into a new state, outcome state into a new state and the reward. After we have taken the action, now it's time to update our current, the queue table of our current state. So how we are going to do that is we are going to update the queue table of the current state by using this formula where we are uh, updating this queue table by, which is equal to Q table of the current state plus the learning rate into reward plus gamma into the maximum of the outcome state Q value minus the Q values of the current state. So once we have updated our current Q table of the state, we are going to update our total rewards to maintain the cumulative reward state, to maintain the cumulative rewards, and then we'll update our state to the new state. So this is our basic implementation of the Q learning algorithm. Let's execute this and create our Q table. So the time it will take to execute this will depend on the number of episodes and the number of maximum steps we are taking in each episode. This should be fast. And now we have created the score over time, which is 0.499 in our case. So once we have created our Q table, we'll use this Q table to see how our agent plays the frozen lake. I have executed this. As we can see in episode 1, episode 0, episode 2, it reached the goal in these number of steps. But in episode 6, we fell into a hole and the number of steps we took was 6. Here, we just observe the output for the 10 episodes, whereas we have saved the output for 20,000 episodes. So this is our basic example to create a cheat sheet to play the frozen lake. I hope we get the basic idea and motivation behind the reinforcement learning and the Q learning through this example. And in the future videos, we'll go over more examples on this. Thank you.